Today we're going to look at the free radical addition of HBr to alkenes in the presence of peroxides. So normally, when an alkene reacts with HBr, it follows Markovnikov's rule, meaning that the hydrogen attaches to the carbon with more hydrogens and the bromine attaches to the more substituted carbon. This is because we have our carbocation intermediate and we need to have our carbocation on the more stable carbon. But in the presence of peroxides, our mechanism changes completely. Instead of going through regular addition, we're going to go through free radical addition. And this will give us the anti-Markovnikov's product, meaning that the bromine will end up on the less substituted carbon. So let's look at this mechanism step by step. We're going to start like any other free radical addition with our initiation. But the thing is, this initiation is going to have two steps. The first thing we're going to see is what you would typically see for an initiation step. We're going to have our peroxide, and with heat or light, we're going to have a homolytic cleavage and form two radicals. So we need heat here, and then we're going to get our two radicals here. Our second initiation step is going to be similar to a propagation step, where we start with a neutral molecule and a radical. We're going to end with a neutral molecule and a radical. For free radical addition of HBr, we're going to need the Br radical. Right now, we just have our oxygen radical. So our next initiation step is going to be one of these radicals coming into contact with HBr. And then our hydrogen is going to end up attaching to that initial radical, first creating a bromine radical, and then also creating an alcohol, which isn't as important for this. But this is how we get our bromine radical, with two initiation steps. Now, if we go to look at our propagation, we're going to have our alkene come into contact with our bromine radical. We're going to have a homolytic cleavage of this pi bond. One's going to attach to our bromine radical, and the other is going to go on the more substituted carbon. So this is why we have anti-Markovnikov's rule, because we need our free radical to be on the more stable carbon, as it needs the electron density. So our product in this propagation step is going to be our more substituted carbon with the radical, and then our less substituted carbon with the bromine. So we could just say, for this example, these are alkyl groups, these are hydrogens. Now our next propagation step is going to include this radical that we just formed. This radical is going to come into contact with a molecule of HBr. And what's going to happen here is we get another homolytic cleavage. This hydrogen attaches to the free radical, whereas the bromine becomes another free radical to continue this propagation, meaning that our products here will be the exact same thing, except instead of a free radical, we're going to attach the hydrogen to it. So this is where the anti-Markovnikov rule really plays a part, because the hydrogen is going to end up connecting to the carbon that's more substituted, and the bromine is going to connect to the one that's less substituted. And again, that's just because we need to stabilize that free radical. Our termination step is going to be the same as any free radical addition, where we're going to look for any two free radicals that are in the mixture, and we're going to combine them together. The only radical that isn't involved in termination are going to be the peroxides. But everything else, we can just combine together to form a product. So we can have two Br radicals come together and get our Br. We can have the bromine radical come together with our longer carbon chain, and this will give us our dihalide or our dibromide. So if we use the same example, we'll have our bromine attached here, and our product is going to be our vicinal dibromide. And lastly, we can have our carbon chains come together. So we'll have our CH2 with the Br. Here's the second one. And then these free radicals come together, and I'll just put it down here. We'll get our CH2 with the Br, and then our C with our two R groups, forming this new bond with the exact same thing. Like I already mentioned, notice that the peroxides only matter just at the beginning. Those oxygen bonds are weak, and they just break to generate the radicals that start this whole chain. After that, the reaction just runs on the bromine radicals, and by the time we reach the termination, the peroxides are already gone. So if this video helped you out at all, please consider liking and subscribing, as it really helps the channel. If you want to see more organic chemistry videos, there should be the playlist on your screen now. Thank you so much for watching.